guys, welcome back to part 3. In this part, we are going to discuss or learn about how to give name for coordination complexes, the nomenclature of coordination complexes. So as you can see, these are examples for complex compound or coordination compounds. So what you can see here, this is first is complex cation because we have positive 3 here. And then other than that, we have complex anion with negative charge here. We have a neutral complex with no charge at all, 0. And last but not least, we have coordination compound. This is one of example of the coordination compound. So in order to begin the naming coordination complexes, here we have 3 things to keep in mind. First one is you need to give ligand. Okay, ligands are named first in alphabetical order. So means from A, B, C and so on. First, you need to give the name for the ligand. Okay. Second one, the name of the metal complexes comes next after the ligand. And last but not least, when you have metal, transition metal, especially transition metal, we have a few oxidation state, right? So you need to write down this oxidation state of the metal and then noted by using Roman numerical in parentheses, means here in bracket. Okay. For example, let's say we have 2 and also 4. So you need to be able to write down the Roman numerical 1, 2, and then 3, 4, and so on. So, in order to give a name for a coordination complex, first thing, you need to write down the ligands, okay, the ligands first with alphabetical order. Second one, followed by metal. And then third one, you need to write down the oxidation state using Roman numerical in bracket, in parentheses, okay. So, other than that, okay, you need to make sure there is no gap between the metal and parentheses. For example, let's say you write down as a copper. Let's say this one is copper 2. Let's say you have copper 2 plus. Copper, and then make sure there is no space, and this is 2. Okay guys, alright. Then, okay, so we have a few rules here in order to give name for the coordination complexes or coordination compounds. Okay, first one, the first rule is the ligands. Okay, so ligands that actually act as anions, okay, which end in IDE. Let's say you have chloride, fluoride and so on. You need to replace this one with an ending of O. So when you have, for example, chloride, it will become chloro. Let's say you have fluoride, it will become fluoro. Okay, this is all actually for anions. Okay, as you can see from here, chloride it will become chloro, bromide it will become bromo, iodide it will become iodo, and then oxide it will become oxo, cyanide it will become cyano. And then if you have NC minus, this looks like cyano, but this one is isocyano. And then, alright, other than that, rule number 2, okay, this is where when you have neutral molecules that are ligands carry their normal name. Okay, but you have a few, we have few exceptions. The first 4 on the chart here, first one is amine. AMMINE. This is where we call it as ammonia. So in order for you to give a name for coordination compounds, ammonia will become amine with double M. Ammonia with amine. And then water, H2O, it will become aqua. And then CO, carbonyl. This is not carbon monoxide in this case. And then NO, nitrosyl. And then methylene amine and also pyridine. Okay, so please note here, amine, this is actually spelled with 2 M's, okay, when referring to a ligand. Other than that, we have polydentate ligands, okay, they actually follow the same rules for anions and also neutral molecules. En is actually ethylene diamine, and then if you have oxide here, this is oxalate C2O42 minus, okay. So let me write down the formula. C2O42 minus, this is oxalate, it will become oxalato, and then EDTA 4 minus here, it will become ethylene diamine tetraacetate. From acetate, it will become acetate. And then we have rule number 3 here. So the number of ligands, okay, present in the complex is indicated with the prefixes. Usually we call it as di, tri, tetra, and so on. But we have a few exceptionals, okay, especially for the polydentates that have a prefix, okay, already in their name. For example, ethylene diamine and also EDTA. So when indicating how many of these are present in the coordination complex, you need to put the ligand's name in parenthesis, so means in bracket, parenthesis, and use the bis, tris, and tetrakis, not di, tri, and so on. This is only for polydentate and also bidentate. Say if you have 2 bidentate or 2 polydentate ligands, it will become bis, not di. Okay, and then if you have 3, it will become tris. If you have 4, it will become tetrakis. And then prefixes always go before the ligand name, so they are not taken into account when putting ligands in alphabetical order. So note that mono often is not used. We rarely use mono. And then for example here, okay, this is example for the iron 2. This is iron 3 complex cation. This is the name where we can call it. First, you need to have ligands, okay, based on alphabetical order. So it will become triamine because we start with A, triamine, and then we have Cl, chloro, triamine chloro, dicarbonyl, di because we have 2 here, dicarbonyl, iron 3 ion. Why this is ion? Because we have a positive 2. So first thing, you need to list down your ligands based on alphabetical order, right? Based on your alphabetical order, and followed by the metal and also the oxidation state. Okay. Then remember, ligands are always named first before the metal. Okay. So if you have a triamine, you need to refer to the A, amine, not the tri. Okay. So this is actually where I have already stated to you, okay, that actually this normal and also this bis, tris, or tetrakis does not taken into account when you putting ligand in alphabetical order. So guys, as usual, I have 3 exercises for you. Please do this and give the name, and we will discuss this one in the class. And I think this is the last one. Yeah, this is the last one for nomenclature on coordination compound. So let's say if you have overall coordination compound is an anion, okay, is an anion, mean you have a negative charge, okay, the ending 8 here, okay, the ending 8 here, let me write it down, okay, the ending 8 here is attached to the metal center. Okay, you need to add 8 overall to the metal center if the coordination complex is an anion. Okay, so iron will become ferrate, copper will become cuprate, tin will become stannate, silver will become argentate, lead will become plumbate, and gold as aurate. So if you have complex anion here, okay, please remember that you need to change the metal here as 8. Okay, attached to the metal center. And then I have 4 exercise for you to do this at home. Please do this. And I think that's the end for today. I hope to see you guys again in next class. So alright, so that's all for today, and have a nice day guys. Bye.